In the apocalypse, the only thing worse than finding no water is finding water that looks like it wants to kill you. And trust me, post-collapse water, it has opinions. Violent, toxic opinions. Check out our merch. Use the discount code YouTube, link in the description. Now let's get back to the video. Today, we're tackling humanity's oldest problem with humanity's newest challenge. Finding drinkable water when everything that used to keep water clean has stopped working, exploded, or been repurposed into a weapon by your neighbors. Let's get started, because dehydration doesn't care about your feelings, and neither does dysentery. So, you've found water. Congratulations, you're halfway to not dying the other half, making sure that water doesn't speedrun your demise faster than dehydration would have. Contaminated water is like a mystery box, except instead of prizes, you get pathogens, and instead of fun, you get violent intestinal distress. Let's talk about what's probably swimming around in that puddle you're eyeing. First up, biological contaminants. Bacteria like E. coli and Salmonella, which normally live in places we don't discuss, but post-apocalypse, they're everywhere. They throw parties in your intestines, and you're not invited, but you're definitely hosting. Then there are parasites like Giardia and Cryptosporidium, tiny freeloaders that'll make you wish you'd just stayed thirsty. But wait, there's more. Chemical contaminants are the silent achievers of the contamination world. Heavy metals like lead, mercury, and cadmium, which don't care about your immune system because they're not playing that game. They're playing the long game, the one where your organs slowly give up on life. Industrial chemicals, pesticides, petrochemicals, and my personal favorite, mystery sludge of unknown origin. That iridescent sheen on the water's surface, that's not a pretty rainbow. That's oil, fuel, or some chemical compound that was probably labeled with a skull and crossbones before society collapsed. And then there's radioactive contamination, which I'm including here not because it's common, but because if your water glows, you need to reconsider your life choices and also your location, because you're standing in the wrong place. The apocalypse has essentially turned every water source into a chemistry experiment designed by chaos itself. Your job is to negotiate with chaos and come out with something you can drink without immediately regretting it. Before we start filtering and boiling, we need to assess what we're working with. Think of this as getting to know your enemy, except your enemy is liquid and possibly sentient. The smell test is your first line of defense. Stick your nose near the water, not in it, because we're careful scientists here. Does it smell like rotten eggs? That's hydrogen sulfide, probably from decomposing organic matter. Does it smell like chemicals, bleach, or that time you mixed cleaning supplies and created a war crime in your bathroom? That's bad. Put it down. Walk away. Does it smell like gasoline or oil? Congratulations, you've found the apocalypse's least refreshing beverage. If it smells like nothing, that's actually suspicious too, because clean water in the apocalypse is rare enough to be noteworthy. Next, the visual inspection. Hold your container up to light. Is the water clear, or does it look like someone made soup with dirt and regret? Sediment is actually one of the easier problems to solve, but if your water has chunks, layers, or what appears to be its own ecosystem, we've got work to do. Look for that oily sheen I mentioned. If you see rainbow patterns on the surface, that's hydrocarbon contamination. You cannot boil away oil, you cannot wish away oil. You can only accept that this water requires more intervention than you probably have supplies for. Now for some improvised chemistry, the fun part where we pretend we're scientists while everything around us is on fire, metaphorically or literally, if you've scavenged any pH testing strips, use them. Water should be roughly neutral, around 7 on the pH scale. If it's highly acidic or highly alkaline, something's very wrong. Acid rain, industrial runoff, or someone's illegal chemical operation upstream is now your problem. No pH strips. Here's a terrible but technically functional test. Put a small amount of water on a piece of aluminum foil or a steel can. If it fizzes, bubbles, or the metal starts corroding rapidly, your water is aggressively acidic. Do not drink angry water. If you have baking soda, add a tiny pinch to a small sample of water. If it fizzes vigorously, the water's acidic. If you have vinegar or any acid, add a drop to another sample. If it fizzes, the water's alkaline. We're doing high school chemistry in a wasteland, and honestly, this is the best use of that education. One more test, the evaporation test. Put a small amount of water on a dark, clean surface and let it evaporate. If it leaves behind white crusty residue, that's dissolved minerals, possibly safe. If it leaves behind colored residue, weird patterns, or what looks like a crime scene, that's contamination you can see, which means there's probably more you can't. Filtration won't fix everything. Let me say that again for the people in the back. Filtration removes particles, sediment, and some biological contaminants, but it does not remove dissolved chemicals, heavy metals, or your poor life choices. But it's a start, and in the apocalypse, a start is sometimes all we get. The most basic filter is layers of cloth, t-shirts, bandanas, that curtain you pulled off a window. Stack multiple layers and pour water through slowly. This removes large particles, debris, and the more ambitious insects. It's not purification, it's particle removal, but it's better than drinking visible chunks. Next level, the sand and charcoal filter. Humanity's oldest water cleaning trick, now with 100% more desperation. Find a container, a plastic bottle with the bottom cut off, a metal pipe, a food can with holes punched in the bottom, anything that can hold layers of material while letting water drip through. First layer at the bottom, cloth or grass to keep everything else from falling out. Second layer, small pebbles or gravel. These provide structure and catch larger particles. Third layer, sand. The finer, the better. This is your workhorse layer. Sand filters out sediment, some bacteria, and particles you'd rather not think about. Fourth layer, crushed charcoal, and this is the important one. Charcoal absorbs chemicals, bad tastes, and some toxins through a process called adsorption, which is like absorption but fancier. You make charcoal by burning wood until it's black, then letting it cool. Crush it into small pieces. The more surface area, the better it works. Fifth layer, more sand, because we're fancy and believe in redundancy. Top layer, another cloth to distribute water evenly across the filter. Pour your questionable water in the top and wait, and wait, and wait some more. Good filtration is slow. If water's rushing through in seconds, your filter is too loose and isn't doing its job. If it's taking hours for a cup, you might have packed it too tight, but honestly, slow is better than poisoned. Now, the charcoal is crucial, so let me explain how to make it properly. Take wood, hardwood if you can find it, and burn it in a loxygen environment. That means covering your fire with dirt or metal once the wood is burning well, choking off most of the air. The wood will smolder and turn black instead of burning to ash. Let it cool completely, because hot charcoal plus water equals steam, scalding, and regret. Once cooled, crush it. A rock in a hard place works. The finer you crush it, the more effective it is. If you can't make charcoal, you can sometimes scavenge it. Old barbecue grills, burnt buildings, anywhere there's been fire, but not complete combustion. Just make sure you're grabbing plain charcoal, not charcoal that's been soaked in lighter fluid or chemicals, because adding petrochemicals to your water filter defeats the entire purpose. Advanced scavenger filtration. If you find ceramic like broken pottery or tiles, you can crush it into small pieces and use it as a filter layer. Ceramic is porous and helps with filtration. Same with certain types of stone. If you're near a beach or riverbed, you can dig a hole about 6 feet from the water's edge and let groundwater seep in. The soil acts as a natural filter. The water that collects will be clearer than the surface water, though still not safe to drink unboiled. Nature's been filtering water through soil for millions of years. We're just borrowing the technique. Filtration makes water look better. Purification makes it safer to drink. These are different goals, and you need both. Boiling is your best friend, your most reliable ally, and the one method that doesn't require you to understand chemistry. Bring water to a rolling boil for at least 1 minute, 3 minutes, if you're at altitude or feeling paranoid. This kills bacteria, viruses, and parasites. It does not remove chemicals, heavy metals, or radiation, but it handles the biological threats that'll make you sick fastest. The challenge in the apocalypse is sustaining fire and having containers that can handle heat. Metal cans work, glass bottles do not. They explode, and exploding glass near your face is bad survival strategy. Ceramic containers work if they're intact. Even certain plastics can boil water if you're very careful. But I don't recommend it, because melting plastic into your drinking water adds a whole new category of problems. If you don't have a container, you can heat rocks in a fire until they're extremely hot. Then drop them into water held in a non-flammable container or even a hole in the ground lined with plastic. The rocks will boil the water. This is called rock boiling, and it's been used for thousands of years by people who had fewer options than you do. Add rocks, wait for boiling, remove rocks, add more hot rocks, repeat. It's labor-intensive and slightly ridiculous, but it works. Now let's talk about solar disinfection, or SODIS, which sounds like a drink brand, but is actually a legitimate purification method. Fill a clear plastic bottle with filtered water, shake it to oxygenate it, then lay it in direct sunlight for at least 6 hours, ideally longer. UV radiation from the sun kills pathogens. This doesn't work with cloudy or colored bottles. It doesn't work on cloudy days. It doesn't remove chemicals. But if you're low on fuel for fire and have time and sunlight, it's an option. For the truly ambitious, you can build a solar still. Dig a hole, place a collection container in the center. Fill the area around it with wet soil, vegetation, or even contaminated water. Then stretch plastic over the hole and weigh down the edges with soil or rocks. Place a small rock in the center of the plastic to create a low point directly above your container. As the sun heats the hole, water evaporates, condenses on the plastic, and drips into your container. This is distilled water, which means it's evaporated and recondensed, leaving behind most contaminants. The problem with solar stills is they're slow, producing maybe a liter per day in good conditions. They're survival gear, not a long-term water solution, but in a pinch, they work. If you've scavenged any alcohol, high-proof stuff above 90 proof, you can use it as a disinfectant. Add a capful to a liter of water and let it sit for 30 minutes. The alcohol kills some pathogens. It's not as effective as boiling, but it's better than nothing. Bleach is another option. If you find unscented household bleach with sodium hypochlorite as the only active ingredient, 2 drops per liter of clear water, 4 drops if the water's cloudy. Mix and let it sit for 30 minutes. It should smell faintly of chlorine. If it doesn't, add another drop and wait longer. Too much bleach is bad, but not enough bleach means you've just diluted bleach into your water without actually purifying it. Iodine tablets also work if you scavenge them from camping supplies or emergency kits. Follow the package directions, but generally, it's 1 or 2 tablets per liter. Wait 30 minutes. Iodine makes water taste like a chemistry set, but it kills pathogens. Now we've reached the part of the tutorial where I describe in vivid detail what not to do. Because education includes learning from other people's mistakes, so you don't have to make them yourself. First, do not attempt to neutralize acidic water by adding random alkaline substances you find. Yes, chemistry says acids and bases neutralize each other. Chemistry also says that mixing them can generate heat, produce toxic gases, or create new compounds that are worse than what you started with. One person's "I'll just add some lye to this" acid water is another person's chemical burn and a cloud of chlorine gas. Don't be that person. Do not assume that because something was used to clean water before the apocalypse, it's still safe to use. That drum of chemicals you found in a water treatment plant, you don't know what it is. It could be chlorine, which in the right concentration purifies water. It could also be aluminum sulfate, ferric chloride, or some industrial compound that's toxic at any concentration. If you don't know what a chemical is, don't put it in your drinking water. Do not try to boil off chemicals. Some chemicals evaporate when heated. Some chemicals concentrate when water evaporates. You could be boiling water and accidentally creating a toxic soup that's more dangerous than what you started with. Petroleum products, many solvents, and certain heavy metal compounds become more concentrated as water boils away. Congratulations, you've made poison reduction sauce. Do not mix different purification methods without understanding them. Someone once told me they combined bleach and vinegar to super purify their water because 2 disinfectants are better than 1. That person created chlorine gas, which is a war crime when used deliberately and a tragedy when created by accident. Bleach and anything acidic creates toxic gas. Don't do it. Do not filter water through materials you don't understand. That pink insulation foam contains chemicals. That colorful fabric from a tarp, probably treated with waterproofing compounds. Random filters from appliances or cars could contain lubricants, coolants, or materials that leach toxins. If you don't know what something is made of, it doesn't go in your water system. And finally, do not drink water just because an animal drank it and survived. Animals have different digestive systems, different tolerances, and different timelines for getting sick. A deer can drink from a stream, walk away looking fine, and be dead from parasites a week later. You don't have a week to find out if water is safe. Use proper purification methods. Let's have the serious conversation now. The one where I tell you the limitations of improvised water purification, because hope is good, but false hope gets you killed. Filtration and boiling do not remove dissolved heavy metals. If your water source is downstream from a battery factory, a mine, or industrial waste, no amount of sand filtering or boiling will make it safe. Heavy metals pass right through physical filters and don't care about heat. You need chemical filtration, reverse osmosis, or distillation. In the apocalypse, that likely means finding a different water source. Radioactive contamination cannot be fixed with improvised methods. Radioactive particles can be filtered out if they're attached to sediment, but dissolved radioactive isotopes are in the water at a molecular level. Boiling doesn't help. Charcoal doesn't help. If you're in a fallout zone, your only option is to move, find groundwater from deep wells that hasn't been contaminated, or wait for decay, which, depending on the isotope, could take years. Some chemical contamination can't be removed without specialized equipment. Pesticides, certain industrial solvents, and petrochemicals are persistent. Activated charcoal helps with some, but not all. Distillation helps more, but it's energy intensive and slow. If water tastes like chemicals, smells like chemicals, or makes your mouth tingle or burn, do not drink it. Your body is telling you something is wrong. Listen to it. If you drink water and immediately feel nauseous, dizzy, or experience unusual symptoms, stop drinking it. If you have any way to induce vomiting safely, do it. Seek cleaner water. Your body is better at identifying this as poison than your brain sometimes is. Also understand that clean-looking water can still be contaminated, and dirty-looking water can sometimes be made safe. Appearance is a clue, not a diagnosis. Always filter and purify, no matter how good water looks. Finally, understand the order of operations. Filter first to remove particles, then purify to kill pathogens. If you boil water full of sediment, you get hot, dirty water with dead bacteria. If you filter water but don't purify it, you get clear water with live bacteria. Both steps matter. So here we are, at the end of our journey through the world of apocalyptic water treatment, where every day is a science experiment and every sip is a calculated risk. You've learned that contaminated water is a complex problem with multiple solutions. None of them perfect, all of them better than dying of thirst or dysentery. You've learned to identify threats, improvise filters, purify through heat and chemistry, and most importantly, recognize the limits of what you can fix with scavenged materials and determination. Clean water is the foundation of survival. Everything else, food, shelter, defense, becomes irrelevant if you're too sick to function because you drank bad water. Prioritize water, respect water, understand water. And remember, in the apocalypse, the goal isn't perfection. The goal is good enough. Good enough to survive another day. Good enough to stay healthy while you figure out the next problem. Good enough to keep going when everything else has fallen apart. You'll make mistakes. You'll drink questionable water because you have no choice. You'll probably get sick at some point, despite your best efforts. That's the apocalypse. But with knowledge, preparation, and a healthy respect for chemistry and biology, you increase your odds. Clean water keeps you alive. Explosions, despite being entertaining and occasionally educational, are optional. Stay hydrated, stay skeptical, and stay alive.